Okay, in our last video, we went over different data types and data structures that we use in R. And one of the most common ones that you'll run into is a data vector. Now, a vector, if you remember from what we went over last time in the other video, it's a one-dimensional data structure that holds a single type. Now, vectors are really important because what you can do with them is you can tie them together to become a data frame. And data frames are probably one of the most common and useful types of data structures that you use when doing data analysis, because it can hold tables of multiple types of information. So let's go ahead and jump in and create multiple vectors of different types and tie it together into a data frame at the end and analyze it a little bit. So first off, we're going to create a numeric vector of GPAs, the grade point average. And so I'm going to name this vector GPA, use the combine function, and manually put in the GPAs of the students. So we'll run that. And it's important to note that R, as opposed to other programming languages, if you have other programming experience, you'll know that most programming languages are zero-based language. The index starts at 0. R starts at 1. And so the first element is actually index 1 and not index 0. That's just a side note for those of you who already have programming experience. So now we want to get a series of values. Use the colon to say I want everything between the first index and the third index. And you run it and it gives it everything back, and the third through fourth. Now let's go ahead and look at the structure. STR stands for structure. So we know it's a numeric vector and it contains those variables. Let's look at class. Again, numeric. It'll tell you what data type is in there. And summary. So again, since this is a numeric table or vector, it will show you what each one of these are. So if you want to learn more about those functions, again, use the question mark, str, whatever you're curious about. So now let's make a character vector. And these are the first names of the students that have these GPAs. So we're going to use the combine function, and again, just choose random names. Let's go ahead and combine those. And now we have a first name vector. It's from str for structure. We know it's a character, has series 1 through 4. Class is character. Now let's look at what summary does, since this is a non-numeric vector. Basically, it just tells you that it has a length of 4, similar to what the structure told you, and the class is character. So it's not as informative with summary, but it's still helpful. Now let's go ahead and create a logical vector, and we'll call it pass. And this will indicate whether the student passed or failed the courses or the semester. So we'll use the combine function once again. We'll run that. And these are logicals, and the logicals are case sensitive, so it has to be all caps. Let's look at structures, logical 1 through 4, class, logical, and again, let's see what summary does, since this is a non-numeric vector. So this is helpful because now we know how many trues and how many false are contained in this vector. And especially if you have lots of data, you can run this pretty quick and get to know what the ratio is. Now let's create another factor called gender, and this will be F for female, M for male, and we'll look at the structure of it. It's a character vector. Now, this brings up an interesting point about data analysis. This gender vector is a little bit different compared to the other character vector that we made up here for first name. And the reason being is because these first names are unique values for each student. That won't always be the case in data analysis when using first names, but for this table, this is a unique identifier for them. If we look at female and male, those are more categories than they are unique values. So instead of having a character vector, we want to put those into a factor. And the factor means it's buckets of categories. And R will easily interpret those and help us do a much better job with analysis if we have those categories defined. So we'll say gender and then call the factor function, which means we're going to force gender to be a factor, pretty much these categories of male and female. So now let's look at structure. So we know it's a factor with two levels, female and male. And the ones and twos represent kind of the binary, it is or it isn't, or whatever category it is. So in this case, 1 is a female, 2 is a male, since those are the levels of the factor. Now it's a factor. Let's see what summary does. Again, it kind of tallies it up for us down here. We see it, there's female, 2, male, 2. So now let's create another factor vector, but let's use more concise code. You don't have to create the character vector first and then change it into a factor. Let's go ahead and make it a factor right off the bat. So this will be favorite color. F color equals factor. Whatever we put in here is going to be forced into a factor. So we want to know their favorite colors. We have to use the combine function since we're combining multiple values. We'll do blue, green, green, red. So let's go ahead and combine those into a factor. Let's look at some details of it. No, F color not found. There we go. Factors with 3 levels. So I identified that green is repeated. So it said, okay, you only got 3 levels in here. And let's look at summary. And it says you got 1 blue, you got 2 greens, and you got 1 red. So notice that it puts it in alphabetical order automatically. If we wanted to order them differently, then we could do so by specifying, by doing the following, but just by saying F color equals factor, combine, and then levels. Levels is an argument or a parameter that you can pass to the factor function. So if we come down here, we can see levels, an optional vector, it's a unique set of values sorted into increasing order of x. So we can basically just tell it, hey, order it by going red first, and then green, and then blue. And then if we look at summary F color once again, you'll notice that the order is different now. Now it's red first and blue last, with green still in the middle, because we defined it that way right here. So now this is where we're going to get to a data frame. We have all this distinctly different information in these completely separate vectors that we've created, and we want to be able to put them together to be able to have an effective way to analyze it. So let's go ahead and look at what a data frame is real quick. Basically, it has multiple columns, multiple rows, and it can hold various data types. But the caveat is that each column has to be of the same data type. And this is actually a very, very helpful rule to follow, because it'll help you later on when you are performing different analysis. So let's call it DF1 for data frame 1. We'll call the data frame function, and then we'll pass it the first name, gender, GPA, pass, F color. Now these should sound familiar because these are the vectors that we just made. And so this is the order that we wanted them in the data frame. Let's go ahead and run that and pull up the data frame down here. And as you can see, now we have nicely ordered columns with first name, gender, GPA, pass, and F color. So if we look at the structure of this, it'll tell you each column and it'll tell you what kind of data type it is. And this is helpful because when you put data into a data frame, you want to make sure it's in the best possible format to analyze. And one of the things that you should notice about this data frame is that first name was converted to a factor. You have to ask yourself, is this something that we want? And the answer to that question is no, because the names are the unique identifiers for these students. And so you don't want to put them into categories, because then if there was another Alice, it would just say, a category of Alice. And we don't want her to be a category. We want to keep track of the unique individual Alice. So we're going to have to change that. Now let's continue in class. It says it's data frame, summary. Okay, so it says there's one Alice, there's one Jimmy, and again, this is a result of it being a factor. Once it's a character vector within the data frame, it won't have the same output. But then this is helpful over here when we run summary. We know there's 2 females, 2 males, and we can see the spread of the GPAs. We can see how many have passed and how many have failed, whether it's true or false. And we can see the categories of their favorite colors. So already we're getting to know this data pretty easily since it's in a data frame. We get this big picture perspective and view by using summary. So let's go back and let's make sure that these names stay as character variables and not factors. And the way we do that is call the data frame function again, pass it everything you're going to pass it, but this time use strings as factors equals false. And if we look over here at the documentation, it tells us this is illogical, meaning it's a true or false, and should character vectors be converted to factors? And in this case, we don't want that. So let's go ahead and run that. And then look at data frame 1. So it looks the same, but if we look at the structure again, first name is now a character and it's no longer a factor. And the gender remained as a factor because when it was passed in originally up here, it was already a factor. And so R interpreted it correctly and left it alone. If we run summary again, first name here, length of 4, there's 4 names, and it says it's a bunch of characters. So now we have this data frame of the students and what gender they are, their GPA, whether they passed or failed, and their favorite colors. And now let's do some practicing to pull data from these data structures. So since we're working with multiple vectors, we can use kind of the same process that you pull out of different matrices, another data structure that I talked about in a different video. So if we want the first name, we want the first name. So we want to get Alice right here. We're going to say first row and first column. Get the item that is intersected at that point. So if we run that, we see Alice pulls up. Now we want to get the GPA of the third person. So we're basically saying the third observation, the third row, and we know that the GPA is the third column, 1, 2, 3. So we can say data frame 1, 3, 3, and it pulls back 3.5. Now what if we want the data from all the data from one of the rows? And we do that by specifying which row we want and then doing a comma and leaving this blank at the end. And leaving this blank says, I want everything in that column. Don't leave anything out. So we run that, we get everything back from Sarah. And it's super helpful to analyze a single variable and see what's going on. Now if we want to get all the GPAs and maybe put it back in its own vector and do some further analysis, we could simply put GPA's vector equals df, and then we'll leave the row blank, comma, 3. And so if we look at GPA's vector, we got all the GPAs there. And just continuing, some other ways you can do that is a colon, and this will get, you want 2 through 3. If this was a bigger one, a bigger data frame, you could say 2 through 99. I want everything there. In this case, we're just going to do 2 through 4, and it gets Jimmy through Sarah, because they were the second row, third row, fourth row. Now what if you don't want them sequentially? Well, you have to use the combine function as one of the parameters for rows, and you specify which ones you want. So you're saying you want the first row and the fourth row, comma, and then you left this blank, meaning we want everything on those two people. So you run that and you get the first and the fourth. And the same is true if you do it with the columns, if you want the first names and their favorite, if they passed or not. You can see that really quickly as well. And there's different ways you can do this. You can do conditional extraction as well, where you say data frame, and this may look a little intimidating, but if you take this out real quick and say which data frame $pass equals true. What this is saying, this is a way to search for a specific value of a parameter. And so you say which one in data frame 1, and then you use this $sign to specify which column you're talking about. And then you say, okay, which one's passed? And then double equals true. 2, 3, and 4. Now that's not very helpful. Those are just the index numbers of each one of the people that passed. And so if we want to get a little more specific, we follow the same format that we used up here, this rows and columns. And since we know that this passes back an index value and not the actual people, we're going to just pass the results of this through to the data frame and pull that back. So it's pretty powerful if you're looking for conditional values in there. And this is another example of it. If you're working with numeric variables, you can say get everybody back who got a GPA greater than 3.0. And again, it pulls them back. It happens to be the same people that passed. But again, this is very powerful to use this which function. You're able to pull back conditional data. So this is a basic introduction to the power of data frames. It's a lot more powerful as you continue to study the data frames. Good luck with that, and keep up with some other videos if you need some help.